Dear students, welcome to our fourth class on chapter 2, solar radiation. This is the last theory class of our chapter 2. Now, before we go into our class, I just tell you a small story. The story is on an ass, a hen, and a lion. An ass, a hen, and a lion. Now, an ass and a lion, and a hen are involved in this small story. The ass and the hen were living in a straw ad together. A lion, which was very hungry, approached the spot. He was about to spring upon the ass. Immediately seeing the lion spring about on the ass, the hen just gave a voice of its own sound. Then the crowd loudly. Within a fraction of few seconds, when it crowed loudly, the lion fled away as fast as he could. The lion fled away. By seeing this, the ass thought that just mere crowing of the hen, the lion fled. Why cannot I gallop after the lion? What it does, let me see. It may flee much faster than the crowd voice of a hen. So the ass summoned courage and attacked him by galloping after the lion. When the lion turned behind and see the running ass is caught, and the lion tore him to pieces. So what is the moral? False confidence often leads into danger. The ass has false confidence. Just by seeing a hen crowd loudly when a lion fled, it thought that it can run or gallop very fast, and the lion may flee much faster. However, the lion seized him and tore him into pieces. So what is the moral? False confidence often leads to danger. Now, so coming to our class, very simple, very interesting class, very interesting. In this class, small 3 subheadings we are learning: basic radiation terminology, results of research on effect of solar radiation on most important crops, and finally the units of measurement. Now, basic radiation terminology. The first one is short wave radiation. This is a part of the solar spectrum having wavelength less than 4 microns. Short wave radiation is less than 4 microns. Long wave radiation, it is also known as the terrestrial radiation. Okay, long wave radiation is defined as or explained as the terrestrial and atmospheric radiation, which are in the wavelengths between 4 and 120 microns. Short wave radiation is less than 4 microns. 4 to 120 microns are long wave radiation. The next one is net radiation. The difference between the incoming radiation from the sun and the outgoing solar radiation from the earth is known as net radiation. The difference between the incoming and outgoing is known as net radiation. What is the solar constant? It is the energy falling in 1 minute on a surface of 1 square centimeter at the outer boundary layer of the atmosphere held normal to the sunlight at a mean distance of the earth from the sun. Once again, for your benefit, I just would like to explain. At the mean distance between the sun and the earth, if you presume that a square centimeter area is there, how much sunlight is falling is known as solar constant. The units of measurement of solar constant are calories per centimeter square per minute. Here calories per centimeter square is known as Langley. The estimated value of solar constant is from 1.94 to 2 Langley per minute. The average value is 2 Langley per minute. It is estimated value ranges from or varies from 1.94 to 2 Langley per minute. The average value is 2 Langley per minute. So, it depends on output of the solar radiation, distance between the earth and the sun, transparency of the atmosphere, duration of the sunlight period, the angle at which the sun's rays strike the earth. So, this is what is solar constant. Now, we try to understand what is short wave radiation. Less than 4 microns, long wave radiation between 4 and 120 microns, net radiation, the difference between the incoming and outgoing radiation, solar constant, presuming that 1 square centimeter area is there at a mean distance between the sun and the earth on the top of the atmosphere. The energy falling is known as solar constant. It ranges from or varies from 1.94 to 2 Langley per minute. Calories per centimeter square per minute is known as Langley per minute. Calories per centimeter square is also known as Langley. Now, so let's go to black body. It is an ideal hypothetical body which absorbs all the electromagnetic radiation falling on it. It never reflects nor transmits any radiation striking it. Now, so a black body is an ideal hypothetical body which absorbs all the electromagnetic radiation falling on it. It neither reflects nor transmits any radiation striking it. However, when heated, it emits all the possible wavelengths of solar radiation and becomes a perfect radiator. When it is heated, it becomes a perfect radiator. So, an ideal black body is a perfect absorber and a perfect radiator. An ideal black body is a perfect absorber and a perfect radiator. Now, what is black body radiation? The radiation radiated by an ideal black body is known as black body radiation. Now, quickly let us sum up. So far, radiation terminology we studied are short wave radiation, long wave radiation, net radiation, solar constant, black body radiation. Now, with reference to crops, there are 5 radiation terminology which we often use. These are emittance, absorptivity, reflectivity, transmissivity and albedo. Emittance, absorptivity, reflectivity, transmissivity. Emittance is the ratio of the emitted radiation of a given surface at a specified wavelength to the emittance of an ideal black body at the same wavelength and temperature. Okay. For your benefit, I just repeat once again, it is the ratio of the emitted radiation of a given surface at a specified wavelength to the emittance of an ideal black body at the same wavelength and temperature. This bit will come ideal black body, fill in the blank. Okay, right. Now, absorptivity for an object, this is the ratio of electromagnetic radiant power absorbed. 2. The total amount of radiation incident upon the same object. I just repeat it. For an object or for a crop can be, this is the ratio of electromagnetic radiant power absorbed to the total amount of radiation incident upon the same object. Reflectivity. The ratio of the monochromatic beam of electromagnetic radiation reflected by a body to that incident upon it. Okay. The units of expression is percent. Transmissivity. This is the ratio transmitted to the incident radiation on a surface, preferably a crop canopy. So, absorptivity, reflectivity and transmissivity almost equal to incident. When the incident radiation is occurring, okay, it is either absorbed or reflected or transmitted. Little is converted to photosynthesis that we convert after, we discuss after 1 minute. And the last radiation basic terminology is the word or term albedo. It is the ratio between the reflected radiation to the incident radiation on a crop field, snow, leaves, etc. Reflectivity, the ratio of monochromatic beam of electromagnetic radiation reflected by a body to that incident upon it. It is monochromatic beam. In case of albedo, it is the ratio between the reflected radiation to the incident radiation on a crop field, snow, leaves, etc. For white bodies, the albedo values are high. For fresh snow cover, the albedo values range between 75 to 95%. For cropped fields, it is 12 to 13. Dark cultivated soil, 7 to 10%. For human skin, 15 to 25, etc., etc., etc. for different bodies. Albedo determines how much of the heat that reaches the ground in the form of radiation will remain available for use. This is the scientific use of albedo term. Now, we tried to understand some basic radiation terminology: short wave radiation, long wave radiation, net radiation, solar constant, black body radiation, emittance, absorptivity, reflectivity, transmissivity and albedo. Now, the second part of our last lecture is results of research on effect of solar radiation on important crops like rice, groundnut, sugarcane and cotton. It's very interesting. Research on these crops revealed that solar radiation affects the rice crop, the groundnut crop, the sugarcane and cotton in several ways. Let us have a small discussion on how the solar radiation affects rice crop. Now, the photosynthetically active radiation, PAR, it is also known as light, 0.4 to 0.7 micron. The PAR available at the canopy, its interception and utilization by the crop determines to a large extent the yield and quality of rice. The solar radiation requirement of rice differs from one growth stage to another. Shading at vegetative stage slightly affects the yield and yield components. Shading at vegetative stage. What exactly does it mean? Due to clouds, some shade occurs. It affects slightly at the vegetative stage, but shading at the reproductive stage has a pronounced effect on spikelet number, and during the ripening the shading reduces the yield considerably because of a reduction in percentage of field spikelets. An average of 300 calories per centimeter square during the reproductive stage makes rice yields possible at 5 tons per hectare. In tropical regions, the solar radiation is higher in dry means winter season, than in the wet season. Wet season means Kharif season. Consequently, the dry season yields are higher. Excessively cloudy weather during the wet season is often considered a serious limiting factor for rice crop production in monsoon Asia. So that's why the same variety in Kharif gives less yield as compared to same variety grown in the Rabi season where the cloudiness is almost nil. Another major utility of solar radiation is the solar drying of the paddy seeds and husk. Okay, so this is how the solar radiation affects the rice crop. Just a few points on groundnut. Groundnut responds to full light intensities. Low light intensity prior to onset of flowering slows down the vegetative growth. During the rapid growth, low light intensity increases height and length of the stems but decreases leaf weight and flowering. That is why when low light intensities are there, there is a above ground parts growth or biomass growth in groundnut. But finally, it decreases the leaf weight and flowering, thereby reduction in the yields. Low light intensities suppresses development and growth of reproductive branches in groundnut, consequently a decrease in the total flower production. Solar radiation detoxify. This bit will come. Solar radiation detoxify groundnut oil contaminated with aflatoxins. Solar radiation detoxify groundnut oil contaminated with aflatoxin. Another bit I forgot to tell you in rice. The most important bit, either fill in the blanks or multiple choice that comes, and you also should understand in a scientific way, is in the tropical regions the solar radiation is higher in the dry season than in the wet season. Consequently, the dry season, that is winter season, yields are higher as compared to wet season, that is the monsoon season. In the groundnut, the solar radiation detoxify the groundnut oil contaminated with aflatoxins. Come to our third major crop, that is the sugarcane. Abundant solar radiation is required for accumulation of sucrose in sugarcane. This bit will come. Solar radiation is required abundantly for sucrose accumulation in sugarcane. Of course, when the solar radiation, when sugarcane crops are subjected to full sunshine, they become thicker, they have dark green foliage and thus high sucrose as compared to non-exposed crop canopies to abundant solar radiation. The last crop of our interest with reference to results of research on effect of solar radiation on important crops after rice, groundnut and sugarcane is cotton. Regions recording 60% cloudiness are absolutely unsuited for successful growing of cotton. That means regions recording 60% cloudiness are absolutely unsuited for successful growing of cotton. cloudiness affects fruit setting, and cloudy weather lasting 2 to 8 days causes speedy shedding of fruit in cotton. That means fruit falling is triggered by cloudiness in cotton. So this is what at the basic level you should understand the results of research on effect of solar radiation in important crops: rice, groundnut, sugarcane and cotton. Last 1 minute of the class, what are the units of measurement of solar radiation? Just 1 or 2 units I will tell. Of course, radiant energy joules, radiant exposure joules per meter square, radiant flux, of course, joules per second, that's what we also call it as the watts. Of course, radiation or photon flux density or radiant flux density, irradiance, incident photon flux density, these are all several things of them. Radiant flux density is having the unit with the units is watts per meter square. Now simple, radiant energy joules, radiant flux density watts per meter square. So these are the units. Thanking you for your patient hearing. May God bless you. We meet in our next class.